Okay. Some technical problem is there. So technical people are doing with that. I think it is working now. So, okay. Clear? Yeah. So let us come back to our question, okay? Modulus of x square plus x minus 2 dx, integral from minus 3 to 1. So how to deal with this problem? So, you know, I already told in the afternoon class also, whenever the mod x comes, mod x, you know the definition of modulus of x, that is equal to x if x greater than or equal to 0, okay, and minus x whenever x is less than 0. So this definition actually we have to apply whenever mod of some function comes. Okay. So inside this mode, actually the x whenever x is negative means negative of that you have to take. And whenever x is positive means the same, whatever there. Okay. So the same idea we have to apply here also. So what we have to do is how we can split this mode, okay, where we have to split. So modulus of x square plus x minus 2. So by definition, this must be equal to the same expression, x square plus x minus 2, whenever this expression, the value is greater than or equal to 0. And minus of that expression, whenever the value of this function expression is less than 0. So we have to see where this expression x square plus x minus 2 is positive and where this expression is, this value function is negative. Okay, in the given interval. What is the given interval? We have to integrate from minus 3 to plus 1. So we have to see only that particular interval. Okay, minus 3 to plus 1. That is the interval where we have to integrate. Clear? So minus 3 to plus 1. So in that interval where this x square plus x minus 2 is positive and x square plus x minus 2 is negative, that is we have to check actually. So how to do that one? How to do that one? For that, what we will do, just to factorize this one, x square plus x minus 2. Okay, so x square plus x minus 2 can be factorized very easily. This is equal to x plus 2 into x minus 1. X plus 2 into x minus 1. Okay. So everything depends upon these two factors. Okay. This expression is positive means whenever x plus 2 into x minus 1 is positive. And this is negative means whenever x plus 2 into x minus 1 is negative. Okay. So now we have to see in which interval it is positive and which interval it is negative. So x plus 2, the turning happens at x plus 2. No? Whenever x plus 2 is 0 means you will get minus 2. So one turning point is minus 2, breaking point is minus 2. And another one is 1 actually. 1 means the end point of the interval. 1 is not coming in between. So we can leave that 1. So the turning at the break happens at the point minus 2. That means less than minus 2 and greater than minus 2, the sign of this function in one interval it will be negative and in the other part it will be positive. Okay, so we have to check where it is positive and where it is negative. For that, the better way is you take any value in that particular interval and put it here and see whether it is positive or negative. So let me take a point here in this interval. Okay, in between minus 3 and minus 2. For example, I take a minus 2.5. Minus 2.5, if I put in this expression, x is minus 2.5 means the first one will be minus 0.5. Again, second one is also negative only. Okay, so negative into negative means in that particular interval, this product will be positive. Okay, first term is negative, second term is negative. The product will be negative. You can take any value in between minus 3 and minus 2. Okay, everywhere the same nature will be there. So in this portion, in that interval, the product, yeah, this function value is positive. So naturally, in the other part, it may be negative. You can check. You can take any value in between minus 2 and 1. For example, like you can take 0. 0 is in between minus 2 and 0. All this can be done in your mind actually. Okay. If I put x equals 0, what you will get? The first term is positive, 0 plus 2. Second term is negative, 0 minus 1. So positive into negative means negative. So in the second interval, the function is value is everywhere negative actually. So we got the idea now where it is positive and where it is negative. So accordingly, we have to split the interval as two interval. Okay. So the first interval will be minus 3 to minus 2. Minus 3 to minus 2. And second part is minus 2 to plus 1. Therefore, integral minus 3 to plus 1 modulus of x square plus x minus 2 dx is equal to integral from minus 3 to minus 2, minus 3 to minus 2, first interval, minus 3 to minus 2, where we have to take function is positive. You know, whenever function is positive, mean by definition, it must be equal to the same expression. Okay, as it is. As it is means the given expression is x square plus x minus 2 only. So that is the first integral. Okay. Now plus the second integral. Second integral is minus 2 to 1 actually. 1. 1 is the end point of the interval. Minus 2 to 1. In that interval, the function is negative actually. So when the function is negative means minus of. So minus of x square plus x minus 2. Okay. So whenever the mode comes, okay, we have to break at the turning points. Okay. And again, we have to see less than that turning point, the function sign, positive or negative. Okay. After greater than, in that interval, whether it is positive or negative, like that. Okay. Now the integration is very simple. You know, this is a polynomial. Everybody can integrate and substitute the limit. I think it is clear. So how we have splitted this as two integrals. Okay, the breaking point is minus 2. So how we got that one? By factorizing. Okay, x plus 2 into x minus 1. So one point is minus 2, other point is 1 actually, but 1 is not coming in between. That's why we no need to take the 1. Okay, if some point is coming in between means we have to take that point also. There may be sometimes 3 parts. Okay, three intervals. Okay. Okay. Now we will discuss some more problems from this integration chapter. Okay, some different type of problems. Yeah, hot. You can say like that. Some people are demanding hot questions. No? Okay. So everything depend upon you. Okay, hot or soft or cold. Depend upon your knowledge actually. Okay, so let us take this problem. This question. X square plus 4 upon x raised to 4 plus x square plus 16. So this is a special type of integral actually. So how to integrate it? Okay. So let's see. So what we have to do is we divide the numerator and denominator by x square. So the numerator becomes 1 plus 4 by x square dividing by x square. Both numerator and denominator divided by x square. So the denominator becomes x square plus 1 plus 16 divided by x square. Okay? Dividing both numerator and denominator by x square. So what is the advantage after doing this division? So this can be written as 1 plus 4 by x square, no change, upon the denominator we can express in this way: x minus 4 by x the whole square, x minus 4 by x the whole square. Okay, I have to add one more term actually. Okay, but before that, you just check what is x minus 4 by x whole square actually. X minus 4 by x whole square. If you expand, what you will get? X square. Okay, so x square is here. No problem. Then b square term means minus 4 by x whole square. 4 by x whole square means that is 16 by x square. That is already there. No change. Then 2ab term. Okay, s square plus b square minus 2ab actually. What is minus 2ab here? 2 into minus 2 into x into 4 by x, no? Minus 2ab term. That means you will get minus 8 actually. No? Minus 8 will come. But actually in our original expression, there is no minus 8. It is actually plus 1 is here. Actually, we need a plus 1 only. So we have to add or subtract some number here. Okay, to make it balance. So which number should be added to this expression in order to balance it? Okay, actually minus 8 will come, but actually we need 1 only. 1 is actually here, so that means what we have to add? Plus 9, correct? Because minus 8 plus 9 is 1. Now if you expand it and see, you will get the same thing. No change actually. Okay, x square is there, 4 by x whole square, 16 by x square is there. Then minus 2ab term means minus 8. Minus 8 plus 9. Minus 8 plus 9 is plus 1. Okay. Why we have done this one? Now that's the question. What is the use of this making in this way? You see, in the bracket, the term in the denominator, that is x minus 4 by x. X minus 4 by x. So if I take that term as t, x minus 4 by x t, then its derivative will be 1 plus 4 by x square. No? 1 plus 4 by x square. And that is there in the numerator, you can see. Okay. So that is why we have done all this adjustment. So next step is to substitute after this stage, and just doing the substitution here itself in the right side. Okay. So what I have to substitute? X minus 4 by x. X minus 4 by x equal to t. Okay. X minus 4 by x equal to t. So that means 1 plus 4 by x square, derivative of x minus 4 by x, okay, into dx is equal to dt. Now our problem is solved. Now you can also complete. No? This is equal to, the numerator is dt. The numerator is dt, isn't it? Divided by, what is denominator? Denominator is t square plus 9. T square plus 9. 9, if you want, again, you can write exactly as 3 square. You know? Now, this is one of the standard integral. So, we have reached a standard integral. Okay. And you know the formula. I need not to say the formula actually. This is 1 by a square plus x square form. 1 by a square plus t square. Yeah, a square plus x square form. Isn't it? So, what is the integral? You know, everybody must be knowing. No? 1 by a tan inverse x by a. So 1 by 3 tan inverse t by 3 plus c. Again, t means we have to substitute. The final answer, there should not be any t. Okay. We have to replace by actual value. Okay. Now look at this example, this question. This is actually somewhat similar to the problem what I have discussed in the beginning. Almost same idea, same concept only. Mode of something, mode of x cube minus x, mode of x cube minus x. And we have to find the integral from minus 1 to 2. Minus 1 to 2. That means we have to see the sign of this term in this interval, how it changes, where it is positive, where it is negative. That's all. The same idea. Okay. Either it will be positive or somewhere it will be negative. Mod x, the nature is like that. Mod x will be negative, minus of x somewhere, and x at somewhere, some interval. So, where we have to break in between minus 1 and 2, that is the question. Okay. For that, what to do? The same technique. You consider x cube minus x. X cube minus x. So, x cube minus x can be written as x into x square minus 1. Yeah, x square minus 1 again factorized as x plus 1 into x minus 1. Okay. X cube minus x can be easily factorized as x into x square minus 1. Again, x into x plus 1 into x minus 1. So very clearly we can see the breaking points. No? One factor is x means 0. Another factor is x plus 1 means minus 1. Another factor is x minus 1 means 1. Okay. Now you see the given interval where we have to integrate. We have to integrate from minus 1 to plus 2. Only we have to consider that particular interval. Minus 1 to plus 2. So just arrange these points actually. One point is 0. X equals 0. So somewhere here, 0. Okay. The next point is minus 1. Minus 1 means the end point only. That is the end point. That is not coming in between. So we can neglect it. Okay. Then x equal 1. So 1 means somewhere here. So that means we have to break the given function for integration at 0, means minus 1 to 0, then 0 to 1, then 1 to 2. That's clear? Okay. Now the question is where it is positive, where it is negative. Okay. In which interval it is positive and in which interval it is negative. That is the next task. For that, the same technique, whatever we have used for the first example. Okay. In between minus 1 and 0, we have to see whether this function nature, positive or negative. For that, what to do? You take a point in between -1 and 0. Okay, minus 0.5, x equal to minus 0.5, and see, putting here, x is minus 0.5 means this is negative, x plus 1. So minus 0.5 plus 1, minus 0.5 plus 1 means that is positive. X minus 1, minus 0.5 minus 1, that is negative. So negative into positive into negative, that is the nature in this interval. That means it will be positive. Now come to the other interval, 0 to 1. In between 0 and 1, what is the nature of this function? Positive or negative? You take a point in between 0 and 1, 0.5. Okay, 0.5, and check again. Put x equal 0.5 means 0.5 into 0.5 plus 1. So positive, 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 and last one will be negative. 0.5 minus 1 means negative. So here it is negative. The third interval, 1 to 2. Take a value in between 1 and 2. Okay, 1.5. 1.5 means positive, again positive, again positive. So the whole product will be positive. So this is the way we have to break this integral as three integrals actually. Okay. So therefore, the given integral, therefore, our given integral -1 to 2 mod x cube minus x dx equal to, how to split it? First one, -1 to 0, -1 to 0. And again, in that interval, positive. Positive means same thing, mod x equal to x. When x is positive means mod x equal to x. So mod of x cube minus x equal to x cube minus x only, same. X cube minus x dx plus the next interval, that is 0 to 1. 0 to 1. Okay, in this interval, we already identified negative. So negative means negative of, okay? So negative of x cube minus x. Negative of x cube minus x plus third part, okay? Plus 1 to 2. 1 to 2, it is positive. So same function, x cube minus x. So there are three integrals, okay? But in the integration is same only. Everywhere the function is same, no? X cube minus x only. But here one minus is the, you can take this negative outside. Everywhere the function is x cube minus x only. So just integrate, limit will be different, okay? In the first part, the limit is -1 to 0. And second integral, limit is 0 to 1. And third integral, the limit is 1 to 2. I think the remaining calculation can be done by yourself, okay? Okay. Now, the 16th question is actually a textbook example only, textbook problem only. I think you may be knowing actually. I am not doing that one. The 17th one. X plus sin x divided by 1 plus cos x dx. Integral from 0 to pi by 2. Integral from 0 to pi by 2. X plus sin x divided by 1 plus cos x dx. So that is, first we have to do, we have to split this as two parts. Means the first integral, first part is x by 1 plus cos x, x by 1 plus cos x, plus second part is sin x by 1 plus cos x, sin x by 1 plus cos x. Split it as two integrals, okay? And this is equal to 0 to pi by 2 x divided by 1 plus cos x. 1 plus cos x, you can apply a trigonometric identity. You may be remembering 1 plus cos x equal to 2 cos square x by 2. Remember, very important identity. Many times we are using this 1 plus cos x equal to 2 cos square x by 2, cos square of x by 2. If it is 1 minus cos x, 1 minus cos x equal to 2 sine square of x by 2. Okay, identities from trigonometry. So 1 plus cos x is equal to 2 cos square x by 2 dx plus second part also. We apply trigonometric identities, okay? Sin x and both 1 plus cos x also. So sin x can be written as in terms of x by 2, 2 sin x by 2 cos x by 2. Sin 2x is 2 sin x cos x using that formula identity. And 1 plus cos x is same as 2 cos square x by 2. All these identities you have studied and we have studied in 11th class trigonometry. Okay. Many places we have to use these identities. So that is equal to integral from 0 to pi by 2 x into sec square x by 2. Okay. 1 by 2 is also the x by 2 dx plus in the other part, in the second part, 2 cancels, cos x by 2 also cancels, remaining is tan x by 2. Sin x by 2 by cos x by 2 means tan x by 2 dx. So we have not started the integration yet, okay? So before integration, we have done some simplification. Now we are going to start the integration, okay? So what to do? The first integral only we will integrate. The second integral we will keep as it is, okay? The first integral only we will integrate. The second part we will keep as it is. And also the first integral, how we will integrate? X, we will take the first function, okay? And the half sec square x by 2, we will take as the second function. So by writing itself, we can write in that way, okay? X is the first function and half sec square x by 2 is the second function. Apply integration by parts. Integration by parts means first function into integral of the second. Okay, first function into integral of the second. Integral of second means half sec square x by 2. If you know the answer, directly you can write also. Limit is there, okay? Limit we can substitute at last also anyway. 0 to pi by 2. Plus, sorry, first function into integral of second minus, okay? Minus integration by parts. First function into integral of second minus integral of derivative of first function. Derivative of first means derivative of x, that is 1, into integral of second. Into integral of second. Integral of half sec square x by 2, okay? Half sec square x by 2 You can also write directly if you know. And last integral, no change as it is. 0 to pi by 2 tan x by 2, we have to keep as it is. Now, what is the integral of half 6 square x by 2? Integral of half 6 square x by 2. What is integral of 6 square x by 2? Integral of 6 square x means tan x. Integral of 6 square x means tan x. Integral of 6 square x by 2 means tan x by 2 divided by 1 by 2. Tan x by 2 divided by 1 by 2, isn't it? So that means ultimately you will get this half and that half will cancel. So you will get tan x by 2 only. So x into tan x by 2. Otherwise, you see the derivative of tan x by 2. What is the derivative of tan x by 2? That is 6 square x by 2 into 1 by 2. No? That is exactly here. Derivative of tan x by 2 is 6 square x by 2 into 1 by 2. So very clearly, integral of half 6 square x by 2 is tan x by 2. 0 to pi by 2. Limit 0 to pi by 2. Okay. Minus, again, here also, 0 to pi by 2. Integral of half 6 square x by 2 dx means tan x by 2. Plus the last integral, same as it is. Okay. So now what you can observe? What you can observe? Again, we need to integrate or not? No need. Because this is minus integral tan x by 2 dx. Again, plus integral tan x by 2 dx. Limit is also same only, 0 to pi by 2. That means both will be cancelling. Okay. Both the term will be cancelling each other. So what is remaining? Only this term. Okay. When we put the limit means we have to put everywhere. Okay. The everything into x into tan x by 2. That is our integral. So limit is 0 to pi by 2. So that can be easily evaluated, isn't it? Put the upper limit. So pi by 2 into tan pi by 4. Pi by 2 into tan pi by 4 means pi by 2. Pi by 2. Minus lower limit 0. 0 into tan 0 means 0 only. So pi by 2 minus 0. So answer is pi by 2. So you can observe this is also a special integral, no? A special integral. So we have to remember the method always very means that method you have to remember very, very carefully. Now, the next problem, what you can see in the screen, that is a question from the textbook recently asked in the half-yearly term 1 examination. And no need to, I am going on, actually, I think there is no need to do it, okay? You can do it, okay? And 23rd, 23. 22nd also, it's a textbook problem only. All the problems I cannot do in this short period of time. So I will just select some special kind of questions and we'll discuss. Okay. So let us take this example, this question. Sin raised to 6x divided by cos raised to 8x dx. It's a very simple question actually, not that much lengthy. Okay. So what we have to do here, this expression, you just change it. Sin raised to 6x divided by cos raised to 6x into 1 by cos square x. Isn't it? Sin raised to 6x by cos raised to 6x into 1 by cos square x. So then this reduces to sin by cos means tan. No? So tan raised to 6x. Tan raised to 6x into sec square x dx. Tan raised to 6x into sec square x dx. So put tan x equal to t. Then derivative of tan is 6 square. That means it reduces to t power 6 into dt. Okay, t raised to 6 into dt. So it is integrable. Okay, it can be asked for 2 marks. Very simple question. But you should know the technique, the method. Now let us take integral of x cube plus x by x raised to 4 minus 9 dx. X cube plus x by x raised to 4 minus 9 dx. Okay, you can think about it. Okay. Meantime, I will check any comment or anything is there. Any chat? Nothing. Okay. So how to do this one? So you have to split this as two integrals. X cubed by x raised to 4 minus 9 dx plus second part is x divided by x raised to 4 minus 9 dx. Okay, split as two integrals. Then we will evaluate it separately. Okay, let us take it as some I1 and I2. The first integral I1, second integral I2. Then we will integrate it separately. So consider I1. I1 stands for x cubed divided by x raised to 4 minus 9 dx. So how to integrate this one? It's very simple. You just put x power 4 minus 9, everything, the denominator as t. So put x raised to 4 minus 9 is equal to t. So the derivative of x power 4 minus 9 means 4x cube dx. 4x cube dx equal to dt. 4x cube dx is equal to dt. Okay. So we can proceed. So this is equal to x cube dx means 1 by 4 dt then. So 1 by 4 into 1 by 4 constant taken outside and dt divided by t. Okay. So it is very clearly, easily integrable. What is the integral? Everybody knows. So write it. So that's equal to 1 by 4 into log mod t. Okay. Log mod t. What is t? X raised to 4 minus 9 plus some constant. So this is the first part of the integral. So let us put the constant as C1. We will put the final constant as C. We have to evaluate one more integral, na? I2. Now took I2. Take I2. What is I2? I2 is equal to integral x by x power 4 minus 9. X upon x raised to 4 minus 9 dx. So this can be written as, this can be modified as x by x square whole square minus 9. Why writing like this? Because x square, if you substitute x square as t, okay, so derivative of x square is 2x. So actually x is already there. So just to substitute x square equal to t. X square equal to t means 2x dx equal to dt. 2x dx equal to dt, or x dx is equal to half dt. So this integral reduces to 1 by 2, half dt. So 1 by 2 is taken outside. So dt divided by t square minus 9. Okay, t square minus 9. Now it is a standard integral, isn't it? 1 by x square minus s square form. 1 by x square minus s square. You know the formula. Everybody must be knowing all the standard integral formula. So 1 by 2 into, what's the formula? 1 by 2a. 1 by 2a. What is a here? 3. 9 means 3 square actually. Okay. 9 stands for 3 square. So 1 by 2a means 1 by 2 into 3. Log modulus of t minus 3 divided by t plus 3. Integration is over. Put the constant. We put C2. Then the remaining is just replace t. Okay. So 1 by 12 into log of what is t? X square. X square minus 3 divided by x square plus 3 plus C2. So this is our I2. So I1 is already ready there. Equation something we have done given already in equation 1 or something. Okay. So both you have to add together. So that will be the final answer. And C1 plus C2. Now in the final answer, you put it as C. The final constant is C. Okay. Now look at this question. Okay. I am choosing some different examples only. Okay. Dx by 2 sine square x plus 5 cos square x. Dx upon 2 sine square x plus 5 cos square x. So how to integrate it? So what we will do here, we will divide the numerator and denominator by cos square x. Okay, dividing numerator and denominator by cos square x. Actually, numerator means actually 1 is there. Okay, so dividing by cos square x means 1 by cos square x. Directly also you can write 6 square x. The numerator dividing by cos square x means 1 by cos square x, isn't it? And denominator also you divide by cos square x. So first term will be 2 sine square x by cos square x. Sine square x by cos square x means tan square x. Plus 5 cos square x by cos square x means 5 only. So that is equal to 1 by cos square x is what? 6 square x. 6 square x dx divided by 2 tan square x plus 5. 2 tan square x plus 5. I think now this can be easily integrated. The remaining, I think you can do it. You know? Put tan x equal to t. Derivative of tan x is there in the numerator to receive it. You know? So this reduces to dt by 2t square plus 5. Okay, I'm just writing after substitution, what happens? This become dt. If I take tan square as tan x as t, okay, tan x is t, then the integral reduces to this way, dt by 2t square plus 5. I think this can be easily integrated. You know, there is no difficulty. It's a standard formula. If you want, you can take 2 outside. Then it becomes t square plus 5 by 2. You know? So becomes 1 by s square plus x square form. 1 by s square plus x square form. So that is the standard integral. Everybody knows the formula actually, isn't it? So you can complete by yourself, okay? Any suggestion is there? Any doubt? Any question? Nothing. Okay. So let us take this question 42, question number 42 here, okay? X square by x raised to 4 plus x square minus 2 dx. X square by x raised to 4 plus x square minus 2 dx. So how to integrate this one? So whatever the problems, what I am discussing here, so please you remember it forever. Okay, you again make a practice after this class or whenever you are free. Again, you make a practice of these problems. Okay, if you keep on practicing, then only it will be remembered in your mind. You just if you listen this class and later if you are not at all looking at these problems, means again you will forget. So better to recall again and again and again. You make the solution in a notebook or somewhere and sometimes just revise it. Okay, so that all this method will be coming in your mind and all this will be helping you in your examination. Okay, so how to integrate this one? Any idea? You can see the denominator. The denominator, if I put x square as t, for only for the not for integration, I am telling, just for a factorization. Okay, if I take x square as t, yeah, just imagine in your mind also x square is equal to t. So this becomes, the denominator becomes actually t square, okay, t square plus t minus 2. Just imagine x square as t, x square as t. Not for integration, okay, remember, only just for a factorization purpose I am telling. Now this can be factorized very easily, okay, this can be factorized very easily. In the beginning, the same expression was there in that question actually. Okay, anyway, it is t plus 2 into t minus 1, isn't it? T plus 2 into t minus 1. You can multiply and verify. So that means this denominator can be factorized as t. T means actually x square, okay? T plus 2 means x square plus 2. X square plus 2, t minus 1, that is x square minus 1. So we have just factorized the denominator. We have factorized the denominator. How we have factorized means just I have shown here. Okay. Then what is the next step? I think a similar problem, maybe I don't remember exactly, in that first term examination. Okay, anyway. So how to do afterwards, after this stage? Okay. Now this can be, again, this x square, I will consider as a u, something, a y. X square, I take it as some y for the, not for integration, okay? Not for integration, for some simplification purpose. So that means this expression reduces to which form? Y divided by y plus 2 into y minus 1. Remember, y plus 2 into y minus 1. If I consider x square as some y, this expression reduces to y divided by y plus 2 into y minus 1. Not for integration, okay? Don't write 2x equal to, 2x dx equal to dy. We are not doing integration, okay? Just for some partial fraction purpose, I am telling. Okay, now this can be expressed into the form of a partial fraction. Okay, so that's the idea. So same thing I will write here. Okay, so take y is equal to x square. In bracket, I am writing not for integration. Okay, not for integration. Don't differentiate and write 2y is, sorry, dy is 2x dx like that. So the given expression reduces to x square plus 2 into x square minus 1 equal to y divided by y plus 2 into y minus 1. Y plus 2 into y minus 1. And we have to express in the form of a partial fraction. So that is equal to, what is the partial fraction for the here? One fraction is a by y plus 2. The other fraction will be b by y minus 1. Okay, a by y plus 2 plus b by y minus 1. Okay, say, let it be. Now we have to find a and b. No, how to find a and b already knows. Just compare the numerator. The numerator is y here. So therefore y must be equal to, make the denominator same. Denominator same means a into y minus 1. I am just telling the partial fraction method. Okay, you must be knowing all the method. So a into y minus 1 plus b into y plus 2 divided by y plus 2 into y minus 1. So numerator will be a into y minus 1 plus b into y plus 2. Here the numerator is y. So y must be equal to. Okay. Now find the a and b using some technique. Okay. To get a and b, we can compare the similar terms on both sides, or you can take some value for y. That is, anyway, you can find out. Okay. I put y is negative 2 for the time being, only for finding a and b actually. Okay. Put y is equal to negative 2 means is this 0. So you will get minus 2 is equal to minus 2 minus 1 minus 3. Minus 3 into a, minus 3a. That means a must be equal to 2 by 3. Clear? Then put y equal to 1. Y equal to 1 everywhere. So that means this will be 0 and b into 1 plus 2. That is 3b. So 1 is equal to 3b. That implies b is equal to 1 by 3. Okay. Somehow we have to get a and b. For that, the best method is you just put some values for y. Okay. Otherwise, you can compare both sides, the coefficients. That also can be done. Okay. So anyway, a is 2 by 3, b is 1 by 3. So substitute these values here. Okay. A by y plus 2 plus b by y minus 1. So a is 2 by 3, b is 1 by 3. So our given expression, again, convert in x only. Okay. Therefore, actual expression x square divided by x square plus 2 into x square minus 1. x square plus 2 into x square minus 1 is equal to what? A by, na? A means 2 by 3. A divided by y plus 2. Okay. You see the partial fraction. How we have written? A by y plus 2. Okay. A by y plus 2 means 2 by 3 divided by x square plus 2 plus b means 1 by 3. So 1 by 3 divided by y minus 1. Y minus 1 means x square minus 1. So this is the partial fraction. Now we can easily integrate. Okay. If you integrate, integral of is equal to the first integral plus the second integral. So both are standard integrals. 2 by 3 is a constant, take it outside. So 1 by x square plus 2, 1 by s square plus x square form. You know the standard formula. Second integral also, 1 by 3 is a constant, take it outside. So 1 by x square minus 1, 1 by x square minus s square. That is also, we know the formula, the standard integral. Okay. So the remaining thing you can complete by yourself. Let's take this question. Sine inverse x upon 1 minus x square whole raised to 3 by 2. Sine inverse x by 1 minus x square raised to 3 by 2. So what to do? So here, make a substitution. Sine inverse x equal to some theta, some t. Okay, theta or t or u, doesn't matter. So sine inverse x equal to theta. So sine inverse x equal to theta means what is x? X equal to sine theta. Okay. And dx is equal to cos theta d theta. Dx equal to cos theta d theta. So apply this substitution here in this given integral. Therefore, the given integral reduces to sine inverse x. What is sine inverse x? Theta into dx. What is dx? Cos theta d theta. Cos theta d theta. Again, 1 minus x square. 1 minus x square means 1 minus sine square theta. 1 minus sine square theta is cos square theta. Okay. 1 minus sine square theta is cos square theta raised to 3 by 2. Raised to 3 by 2. So simplify. This is equal to theta into cos theta d theta upon cos square theta raised to 3 by 2. What is the value? Cos square raised to 3 by 2. So square will vanish, na? So remaining is cos cube. Cos cube theta. Okay. Whole square raised to 3 by 2. So square will vanish. 2 into 1 by 2. So cos theta by cos cube theta means, again, cos theta will cancel. So what is remaining? Integral of theta divided by cos square theta. Right? 1 by cos square theta is sec square theta. So ultimately, you will get, finally, you will get integral theta sec square theta d theta. I think this can be easily integrated. How to integrate this one? Integration by parts, okay? The remaining you do by yourself. Integration by parts we have to apply. Take theta as the first function and sec square theta as the second function because we know the integral of sec square theta. First function into integral of sec square theta, that is tan theta, minus integral of derivative of first means 1 only, derivative of theta means 1 only, into integral of sec square means again tan theta. So integration by parts apply. You will get some answer in terms of theta only. Okay, first you will get the answer in terms of theta. So again, you have to go back to x. Theta is only a temporary substitution, only for the integration purpose. So after that, after getting the answer, we have to convert back again in terms of x. Now have a look at this question. Integral of x square by 1 minus x raised to 4 dx. So how to do this one? One thing, you can factorize the denominator. Then just like the previous question, it can be expressed in the form of partial fraction by taking x square equal y and only for partial fraction, and you can make in the form of partial fraction. Okay, but we can do without those process within a short time, without a much effort. So what to do? You see here, this is equal to integral. Okay, the denominator you have to factorize. So what you will get? 1 plus x square into 1 minus x square. Okay, a plus b into a minus b is a square minus b square. Okay, now the numerator is x square. The numerator is x square. So I am going to modify this as like this: 1 plus x square minus 1 minus x square. Is it okay? Can I write like that? What is the ultimate value if I remove the bracket? Actually, it is x square is here. Okay, but now you see 1 plus x square, okay, minus 1 plus x square, minus 1 plus x square after removing the bracket. So 1 and minus 1 cancels, remaining x square plus x square, that is 2x square, but actually it is only x square here. To balance it, what to do? Multiply 1 by 2. Now it is okay, na? A modification, some manipulation in the expression actually, okay? That's equal to 1 by 2 into. Now what is the next step? You have to separate as two parts, two terms. So first term, 1 plus x square by 1 plus x square into 1 minus x square means 1 plus x square cancels. So only the remaining is 1 by 1 minus x square. Okay. Similarly, second term, 1 minus x square will cancel. 1 minus x square will be cancelling. Remaining is 1 by 1 plus x square dx. Now you see, both are standard integrals, isn't it? So integration is over. Both terms are standard integrals, actually means standard formula you know the formula. 1 by 1 minus x square. 1 by 1 minus x square stands for 1 by s square minus x square form. 1 by s square minus x square form. So do you know the formula? And 1 by 1 plus x square. 1 by 1 plus x square is a very standard integral, that is tan inverse x. So the problem is solved, isn't it? Okay, just I am going through your chat. Nothing is there. Happy Dasra. Okay, happy Dasra to all of you. Okay, now let's take another question. Integral root x upon root of a cube minus x cube dx. Root x divided by root of a cube minus x cube dx. Okay, so how to integrate it? Every integral question we have to convert it into some of the standard standard integral form, using some substitution or some other algebra, everything. So that is the final task actually. Okay, finally we have to reach a standard integral, standard non-integral formula. So what can be done here? What substitution can be done here? That's the question. You see, the numerator is root x. Numerator is root x. So numerator is root x dx means naturally we have to think in this way. Whose derivative will come as root x. So in that way, if you think, you will get some ideas and you will come to know where we have to substitute t actually. Simply, if you substitute anywhere, you will not be getting anything. Okay, if I put x cube equal to t, what is the use actually? Put x cube x square equal to t. No use it actually. No. So numerator is root x dx. So if I substitute something as t, whose derivative must be some appearing around nearly root x dx. Some constant can be there, no problem. So in that way we have to think actually. Okay. So if I take t as, suppose I take t as x raised to 3 by 2. X power 3 by 2. Okay, let us try. We'll see what happens. Okay. So dt, if you take the derivative, dt is equal to 3 by 2 into x raised to 3 by 2 minus 1. 3 by 2 minus 1. That means dt by dx, this one, okay, into dx, okay. So 3 by 2 into x raised to 3 by 2 minus 1. 3 by 2 minus 1 means x raised to 1 by 2. Okay, x raised to 1 by 2 means no root x. Okay. So root x dx, we got root x dx. That means we have to substitute x power 3 by 2 as t. Okay. Now, can you see any x power 3 by 2 in this given expression? Directly, I cannot see actually. There is no x cube, x power 3 by 2 here. But we can bring it. Okay, we can modify the term. So that is the first step actually. But you should have this idea. Okay, so this given integral, I will rewrite in this way. root x dx upon root of this x cube. Okay, the first term I will see later. The x cube, that is the important thing. X cube. How to write x cube? X power 3 by 2, x raised to 3 by 2, the whole square. Isn't it? X raised to 3 by 2, the whole square. Okay, now I can put x raised to 3 by 2 as t. Okay, so the a cube. Okay, that also I will modify. That is the constant actually. Anyway, I will write this also in the same style. So a raised to 3 by 2, the whole square. Let it be. Okay, both must be in the same form. Now the same thing. I have already written here. Put t equal to x power 3 by 2. So dt is equal to 3 by 2 root x dx. Okay. Or root x dx will be equal to, we need root x dx actually. Root x dx is equal to 2 dt by 3. 2 by 3 dt. Okay. Root x dx is equal to 2 by 3 dt. So make this substitution here. So 2 by 3 dt. This numerator becomes 2 by 3 dt. So 2 by 3 is a constant. Take it outside the integral. So dt upon root of a raised to 3 by 2 whole square as it is. No change. Okay. Minus x raised to 3 by 2 whole square. X raised to 3 by 2 is t. That means this is t square. Isn't it? Now you see, this is a constant. Okay. A raised to 3 by 2 is a constant. So this integral now reduces to in our standard form. One of the standard integral actually. Which integral is one? 1 by root of a square minus x square form. Okay. 1 by root of a square minus x square form. So you know the formula. Supply the formula. That's all. So what is the formula? 2 by 3 into 1 by root of s square minus x square. That is sine inverse. Okay. Sine inverse x by, here x in place of x, that is t. So t by x by a. In place of a, here the constant is a power 3 by 2. A raised to 3 by 2. Okay. So sine inverse x by a plus c. So integration is over. So just replace the value of t. So that will give the final answer. Okay. So 2 by 3 into sine inverse. 2 by 3 into sine inverse. What is t? X raised to 3 by 2. X raised to 3 by 2 by a raised to 3 by 2 plus c. Okay. We can stop here. That's all. Or if you want, you can write x by a whole raised to 3 by 2. Doesn't matter. Okay. So this kind of problems, you have to remember it, the correct method. Okay. Once you see the problem, see the expression, immediately that idea, that method should come in your mind. So this is the method. This is the substitution recorded here. In that way, you have to store in your mind actually. Okay. So for that, what to do? I already told you. Recall again and again and again. Okay. Write the solution in a notebook, neat and clean, and keep on revising. Okay. Keep on revising. Continuously, if you look at the question, yeah, go through it, it will be automatically stored in your memory. That's the only way to study mathematics and especially this kind of problems.
Sir, good evening, sir.
Sir, good evening. Good evening.
Sir, we are from JNV Chittur, sir.
Okay.
Sir, we have one doubt, sir. If you send your WhatsApp number, we can easily clarify it, sir.
Okay. I will give my WhatsApp number. Okay.
Okay, sir.
My number is, I will write in the board. Okay.
Okay, sir.
9421 230 753. Nine
Thank you,
four
sir.
two 230 753. You can send your doubt at any time. After this
Okay,
class
sir.
also, anytime. Okay, no problem.
Thank you, sir.
Okay. Okay. So look at this problem. Integral 1 by x into root of x raised to 4 minus 1 dx. So what substitution can be done, and where we have to substitute everything we have to think. Okay. So inside the root you can see an x power 4 minus 1. Okay, x power 4, x raised to 4. So naturally we have to think like that. If I substitute x power 4 as t, what happens? The derivative must be 4x cube. Okay, 4x cube dx. Okay. So naturally we have to think like that. Okay, x power 4, if I substitute t, then the derivative is coming as 4x cube, something like that. 4x cube. X cube term will be coming. Okay. But in the numerator, you cannot see any x cube there. Let us try to bring an x cube term there. Okay. Let us try to bring an x cube term in the numerator. So what for that, what to do? Just I multiply x cube. We will see later. Okay. Sometimes we may go wrong also. Then we have to try another method. So multiply x cube in the numerator and denominator. Then the given expression reduces to in this way. X into x cube is x raised to 4. Okay. Now it is clear. You can put the whole thing inside the root. X power 4 minus 1 as t. Okay. X raised to 4 minus 1 equal to t. Therefore, what we will get? 4x cube dx is equal to dt. 4x cube dx equal to dt. Yeah, x cube dx is equal to dt. The dt by 4. Okay. So we have to apply this substitution here. So x raised to 4 minus 1 is t. So here we can see one more x power 4, x raised to 4 here in the beginning. So that also we have to change. So very clearly, x raised to 4 must be is equal to t plus 1. X raised to 4 is equal to t plus 1. So these changes we have to apply here. So then you will get x cube dx, that is dt by 4. dt by 4. So 1 by 4, take outside the integral. dt by 4 divided by x raised to 4, that is t plus 1. t plus 1 into root t. So the integral reduces in this way. dt upon t plus 1 into root t. Now again you think whether is it integrable? Is it integrable? Is there any method to integrate this one? Any known method? Any formula? Because of this root t is a problem actually. Okay, this root t is creating again problem for integration. Okay, so we have to remove that problem again. For that, what we will do? Again, we will make a substitution. Okay, this root t, I will substitute as another variable, another term, that is u, a new variable. Root t is u. Otherwise, we can say that t is equal to u square. T is equal to u square. Then differentiating dt. What is dt? That is equal to 2u du. Dt is equal to 2u du. So these changes apply again in this integral. So 1 by 4 into dt means 2u du. 2u du divided by t plus 1. T means u square. So u square plus 1 into root t. What is root t? That is u. Okay? Is it correct? T is u square. That's the whole substitution actually. Okay. T is u square. So dt is 2u du. So dt is 2u du. T plus 1, that means u square plus 1 into root t, that is u. So that means ultimately this u will cancel. Okay. U will cancel. The remaining is what? 1 by 4 into, this 2 also you can take outside. So 2 by 4 into du by 1 plus u square. Now, it is a very standard integral, a standard formula. Everybody must be knowing the formula. Apply the formula. What is the formula? 1 by 1 plus u square. 1 by 1 plus x square. Tan inverse u. Okay? Tan inverse u. So that's equal to 2 by 4 means 1 by 2. 1 by 2 into tan inverse u plus c. The answer, now the answer is in u. Okay? What is u? U square is t. Yeah, u is root t. So half into tan inverse root t plus c. Again, we have to go back. Okay, we made two substitutions. Now, what is t? X power 4 minus 1. X raised to 4 minus 1. Okay, that's equal to half into tan inverse root of x raised to 4 minus 1 plus c. So that is the final integral. I think the time is already about 8 o'clock. So we have to wind up our class. Okay. So many problems are there in integration. Unlimited problems are there. Only we can do only a limited number of problems within this short period of time actually. Okay. So anyway, I hope that whatever I have taken here, the problems what I have discussed here, it will help you for your examination. So we'll stop here for today. Okay. Some many problems are actually there. Okay, I have a collection of problems actually, but it will take not 1 day, not 2 day, okay, to complete all these problems. So we'll stop here, okay? Now the time is already 8 o'clock, so better to stop. So tomorrow morning again, we will meet at 6:30. Okay? Any comment or anything, if you want, you can put in the chat box. Or you can talk also, no problem. Tomorrow is also maths class is there. Okay, somebody has typed in the chat box. Tomorrow is the last day for mathematics. Okay. Okay then, children. Goodbye. Good night.